Materials used in this video are available from Jameco Electronics. PWM. It might seem like just another one of electronics' many three-letter acronyms, but the fact is, pulse width modulation is a really clever way to use electricity. Let's say I want to control the speed of a motor, because, hey, who doesn't, right? Well, I could use a resistor, but holding back all that power can make my resistor really hot. And if I'm generating unwanted heat, that means I'm wasting power, and really nobody wants to do that. Instead, I can supply full power to the motor, but just in short pulses. A motor takes a little bit of time to respond to abrupt changes. So by powering it with a pulse wave that switches between, say, 0 and 12 volts at a fast rate, our motor will behave as if it's getting a steady voltage, somewhere between 0 and 12 volts. We can determine that voltage level by taking the amount of time our pulse wave is on versus off. This is known as a wave's duty cycle. We then multiply that amount by our pulse's high level. So our signal has an average of 6 volts. Makes sense on paper, but I definitely prefer a more hands-on approach. I'll demonstrate using this pulse width modulator kit. Just have to put it together first. Yeah, where was I? This board uses a specialized chip to convert a DC input voltage into a PWM output signal with a duty cycle proportionate to the DC input voltage level. This will make a lot more sense if we can actually see it. So, to the oscilloscope. I'll use my adjustable benchtop supply to test the board's variable input, and connect my oscilloscope probe to have a look at the output. Turning up the input voltage causes the output's duty cycle to increase. In other words, the pulse's width is modulated according to the input voltage level. So even though that waveform looks pretty harsh and square, it does provide some very smooth and efficient motor control, as expected. Changing or modulating the width of those pulses allows me to control the speed of my motor, and that's pulse width modulation. But PWM isn't just used for motors. The same principle can be used to control a lamp's brightness or even a heating element. Not only that, pulse width modulation is also used as a sort of simple digital to analog converter in many microcontrollers, like, say, on my Arduino board here. This can be really handy when you want to generate a simple audio tone or control the brightness of an LED, make it fade in and out. So in the end, PWM ends up being a versatile and important thing in the world of electronics. And if you ask me, that's pretty wild, man. If you're in the mood to modulate, check out the DC to PWM kit, available at jameco.com.